Recently, Google released its flagship AI tool, codenamed Gemini Pro. If you would like to access this tool from a Java application, this tutorial is going to show you exactly how to do that. I'm going to give you a step-by-step mechanism to make it quick and easy for you to adapt the REST interface into a Java system and thereby work with the state-of-the-art features of Java and Spring to access Gemini. We're going to access both Gemini and its Gemini Vision tool that interprets images as well as text. Welcome to Tales from the Jar Side. Greetings, my name is Ken Cousin and this is the Tales from the Jar Side channel. Our goal here is to help you understand not only cutting-edge technological features, but why you should care and where they help you get your job done more quickly and easily. Let's take a look at Gemini. Now this is the homepage for the Gemini AI documentation. You see it's at ai.google.dev/docs. Now in order to get started with the Gemini API, as it says, you need to get a key. Now they talk about Google AI Studio, and here's what that looks like. Now I've gone to AI Studio, I've created an API key just by clicking on a couple of buttons, and I've copied that key and put it as an environment variable in my system. Now if I go back to the Gemini documentation, you see that they have quick starts for Python or Android or web, which is JavaScript based, or Swift for the iOS stuff, or Go or Node. The part we care about is this REST API Quickstart. So let's take a look at that. In this REST Quickstart, you'll see that the idea is to, after you have set up your key, to take a look at the text-only input approach. This section of the documentation shows you how you could verify your key. Now, I'm not really interested in verifying my key. What I want to show you here is that you have two options with the key. One is you could pass the key as a query parameter, as shown right here, question mark at the end of the URL, key equals with the API key. The alternative is to provide a custom header, x-goog-api-key, and put your key in there as a header. They show this in these curl commands that are passing in the question of give me 5 subcategories of jazz, and so on. Now there's two sections of this REST API I want to focus on in this video. One is the text-only input. We put in a string asking a question and we'll get back some sort of string response. The second one is the text and image input, where we put in a string asking a question and an image as well, and we get back something like a description of the image inside there. We'll come back to that one. For the text-only input, you see in the curl example, they give us a base URL to go to, and this one's using the key as a query parameter, but as I say, we're going to do it slightly differently. The thing to focus on here is that it's a post request, and we have a block of JSON data that we need to put together to transmit in the body of the request. And we also have a block of JSON data that comes back, and it looks fairly extensive in this case. So in this particular example, both of these look a little bit complicated. The first one looks complicated because we have an object with an array with an object with an array with an object. So it's a little elaborate. And the second one looks a little complicated because it's just got so many moving parts in it. There's so many individual pieces. Well, step one in putting this project together is to translate those JSON structures into Java records. That actually is pretty easy to do, but we're going to make it as simple as possible by, hey, that's what AI tools are for. We'll ask an AI tool to do it for us. Let me demonstrate this process, first of all, with the AI assistant inside of IntelliJ IDEA, but you could also use GitHub Copilot, you could use ChatGPT, you could use any AI tool you want. So what you see here is the AI assistant inside of IntelliJ IDEA. Now I have a subscription for this. If you don't have a subscription, there are other AI tools you could use. All I said was, please provide Java records that match the following JSON structure. And what I pasted in here is the input request. So let's take a look. What we see is a sample result that would come from, say, GPT 3.5. I can tell they're talking about GPT 3.5 because they're saying, hey, records were introduced in Java 14 as a preview feature and became final in Java 16. Hey, that's several years ago. We're way more up to date than that. But the important part is look at the record structure they provided. You see, the overall structure winds up as something they just called root, which has a list of content. That's this contents collection. The content record has a list of part. That's this parts collection. And each part has a string in it called text. Now, we're going to do something a little bit more elaborate than that, but it's a start. So let me show you what I'm actually going to wind up using. What I have done is in my Spring Boot application, this is a Spring Boot application using Spring Boot 3.2.0, although 3.2.1 is out now, just the latest version of Spring Boot. And I have a class here called JSON structure. And the reason I did this is so I could put all the records together just so you could see them at one time. There's no reason I couldn't make all the records public and put them in their own files, but then we'd have to jump between them one by one. Now, I made the root called Gemini request, which has a list of content called contents, and then content has a list of parts called part. The part type is where things are going to get interesting. Now, what we're headed for is that part is actually going to be an interface, and I'm even going to make it a sealed interface, because what we just saw was the idea of a text part that has the string in it, just the text. When we pass an image as well, they'll have something called an inline data part, and I'm going to need a mechanism for that as well. So we'll get to that shortly. In the meantime, I have the records I need to pass in text. Now it's time to set up the networking, and Spring is really good about this. Spring 6, which is part of Spring Boot 3, introduced the concept of HTTP exchange interfaces. The cool part here is all we do is add our own interface and tell it what methods we want, and then tell Spring to go ahead and implement the whole thing for us, and we'll be all set. So we won't have to write any of the networking code ourselves at all. We can have Spring do it. So the idea is to say, okay, this is going to be HTTP exchange to this path. Now that path is going to go after the base URL, which we'll see in a moment. This interface has a single method in it called getCompletion. It's going to take a Gemini request as part of the body, and it's also going to take a path variable to indicate the model. Which model are we using? Because this time we're going to use the Gemini Pro model, but shortly we're also going to use the Gemini Pro-Vision model. So that's why this is an HTTP variable inside the post-exchange annotation. If you're familiar with Spring, this all looks pretty straightforward. If not, well, I'll give you this code. It's in my GitHub repository. You're welcome to make whatever use of it you'd like. So the basic URL is going to go to base URL /v1 beta /models / whatever the model is, which will either be Gemini Pro or Gemini Pro-Vision, generate content. We'll pass in our request, we'll pass in the model, and we're good to go. Now, the other thing we need to make this work is a bean to configure the client, the REST client or the web client to do the networking, and a bean to tell Spring to implement this interface. Let's take a look at that class. I have a class here called appconfig.java. So again, this is part of my Spring app. What I have is a bean method. A bean method is a method that puts a bean in the application context, where the name of the bean is the name of the method, the return type is the type of the bean, and inside here I instantiate and configure it and return it. So what I'm going to do in this one is configure the REST client specifically to access Gemini. What I have is an @value annotation that's going to go into my application.properties file and read the base URL. Now this IntelliJ is showing me the base URL that it read out of that file. So I'm going to generativelanguage.googleapis.com. Also, my key, my Google AI API key, was set as an environment variable, and this syntax will tell Spring Boot to read it right out of there. So again, I don't have to put anything in my app at all. That's read as an environment variable on the current system. The next step is to configure this REST client. Now the REST client was added in Spring Boot 3.2, or more properly in Spring 6.1. It's a synchronous web client that makes it easy to do the networking. I'm using the REST client builder to set the base URL, and then I have 3 headers I want to pass in. One is that API key using their custom API name, that x-goog-API-key. Also, I want to send the content type header and the accept header, both set to application/JSON. The content type says this is what I'm passing you, which is JSON data, and the accept header is what I want back, JSON data as well, and then build that bean. So the return type here is the REST client. Again, the REST client was added in Spring 6.1 to be a synchronous client. The other bean I have here is the one to tell Spring that it's time to create an implementation of that interface that I just provided. So it takes in the REST client that I just created, and then the rest of this code is just boilerplate from the Spring documentation. Use an adapter, use a proxy factory, create the client, whatever that is. Again, you just copy and paste that in and you're good to go. So these 2 beans will set up the system so that I don't have to write any further code involving the REST client. So remember how I pasted in the request and configured that into Java records. Let me do the same thing for the response. What you can see here is I pasted in the response from that web page. So it has an object with candidates, with an array, with an object, with content, with an object, with an array. Again, all the way down, there's the text with the story about the magic backpack in it. And then we have things like the role and finish reason and safety ratings and prompt feedback, all this stuff. And let's see what we get out of that. Now this time it looks a little bit more elaborate, but not too bad. Okay, it's a little elaborate. I kind of simplified it. Let me show you the simpler form. So in my JSON structure this time, I let it go ahead and be nested because they don't all have to be top level. Only the parts that I'm reusing in the request and response really have to be top level. So my response, which I called a Gemini response, has a list of candidates, and a prompt feedback. The prompt feedback's down here. My candidate has that content, the same thing I used on the input, a string finish reason, an int index, and then that list of safety rating, and again, safety ratings down here at the bottom. And the content, the new part, has the text part in it and the string role, and that's enough. Now, the only other thing I have to point out to you here is that in Java, we use camel case for field names, whereas in the JSON structure, they use underscores. Now, I could simply rename things like prompt feedback to use lowercase with underscores, but since I do prefer to keep MIME type and prompt feedback and safety ratings and finish reading in camel case, I have to add this Jackson annotation, JSON naming property naming strategies.snakeCaseStrategy.class, as a way to make sure it automatically converts the camel case to snake case whenever necessary. So I had to put that on each record that requires it, but it all works out just fine inside here. So that's what we see. Now, because I don't want the client to have to build up a whole Gemini request and then have to process this big Gemini response coming out, instead what I'm going to do is make a Gemini service. Here's my service class, which is going to have a reference to the Gemini interface inside it. I'm going to auto-wire in that interface and then provide some convenient methods for the users to use to access this. So I have my constants up here representing the models I'm using, Gemini Pro and then the Vision one. I auto-wire in the interface and I have some overloads here, but the basic idea is I'm going to provide text, just the text, and that this method will create the Gemini request with the list of content, with the list of text part, and there's the text in it. Then it will invoke getCompletion, which is the method on the interface that will go ahead and give me my response. And when the response comes back, we'll drill all the way down to the text element. Now, one thing I should mention here, I'm using a neat little feature from Java 21, which is the method called getFirst. GetFirst and getLast are part of what they called in Java sequence collections. And it added getFirst and getLast to a bunch of the collection classes. If you're not using Java 21, if you're just using Java 17, just replace that with get of 0, for example, to get the first element out of a collection. But what the heck, I have it, might as well use it. So you see how all this is doing is just making it more convenient for the user. Now, before we go to the image one, let's run a test and make sure this works. So the test they suggested inside the documentation was write a story about a magic backpack. I'm going to get back my text. I'll make sure it's not null, and then let's take a look. So let me run that. What you can see here I got was this long, complicated story. In a bustling city of Bay Bridge, there lived a young girl named Sophie, blah, blah, blah. It goes on for several paragraphs, and eventually it shaped her into the person she was meant to be. Yeah. Okay, so that much is working. And that's all it took. Again, as a reminder, all we had to do was map the input JSON structure to a series of records, map the output structure to a series of records, use an HTTP exchange interface to do the networking and set up the beans to make that happen, and then auto-wire that into a service so we could simplify the input and output. Now let's go on and see what you would do with an image. The documentation on this section on text and image input says, if an input contains both text and image, use the Gemini Pro-Vision model. In their example here, they're doing something that we don't really need to do. Then they downloaded using curl an image in their storage and saved it locally just to prove that they have an image now. And this is the image they want to transmit. Now down here in the request, you can see the part that's different. So we still have contents and we still have parts, but before all we had was a text part. Now we have this block that they're calling inline data. So it's an object with an inline data, which is an object with a MIME type, and then data, and this is a little command that would work on Unix. Basically, its job is to take the image, convert it into a byte array, and then return the byte array as a 64-bit or base 64 encoded string inside there. So we're still just passing strings, but we need a way to convert the image into the base 64 encoded string. Fortunately, Java's got a built-in way to do that. Now notice how we're mixing the text input with the inline data input. Now, with that in mind, let's see how we can adapt our system to do that. Going back to the JSON structure, remember how I made a sealed interface called part. We've already seen how the text part works. Now I need this, quote, inline data part as well. So the inline data part is also implementing part that has an inline data in it, and the inline data has a MIME type and the string, which is the actual 64, the base 64 encoded string representation of our image. And that's it. So that's the usefulness of the interface, is it allows us to mix both of those into this JSON structure without a problem. Now, how are we going to convert an image and load it in? Let's take a look. Our Gemini interface, interestingly enough, doesn't have to change at all. The interface is still going to do a post exchange. The only thing that changes out of this is the model, and since we made that into a path variable, that can be supplied in the URL and will be good. So now let's take a look at the service. So this time in the service, I'm going to have a method called getCompletion It's still just taking a Gemini request, but this time I'm going to go to the Gemini Pro-Vision model. Looking at getCompletion I'm passing in a string file name. Now, the first part is simple. The content with the text part, it looks exactly as it did before. But the second part is to instantiate a new inline data part with a new inline data. So far, so good. There's the MIME type. I'm going to present a ping file, and then this is the Java code, and this is all standard Java library stuff, which says, hey, go to Java's base 64 class, which is part of java.util, get its encoder, so that will return an encoder that encodes using the basic type base 64 encoding scheme, and it has a method called encode to string that takes a byte array. encodes the specified byte array into a string using the base64 encoding scheme. So all I have to do is read in the file, and I'm going to say files.readAllBytes, and I have an image file in my source main resources folder that'll read in the byte array. That's what readAllBytes will return, the byte array for me. There returns the byte array, which will get encoded into the string, and then I'm good. I've got the whole thing. I could pass that to, once again, I could pass that to the completion, and then get back the response, and once again drill down into the text. Here's the image I'm going to send. It is a cheerful robot leaping in joy because it's happy it completed a difficult task successfully. Now, I created this image using the DALL-E image generator, so it's robots all the way around, AI tools everywhere. Now, in my test case, I'm going to say get completion with image, and the text is simply describe this image, and I'll pass in the cheerful robot, and let's take a look. Now this one takes a bit longer. Here it suggested we used a little over 12 seconds. Didn't feel like it was that long, but the idea was to pass in the entire image as well, and the image is about 1.5 meg in size. Not too bad, but not trivial either. And you see Spring start up and pass in the image, and it says the image shows a small happy robot jumping in the air with its arms outstretched. The robot is surrounded by computer code and seems to be in a programming environment. The robot is made of silver metal and has a blue screen on its chest. And there you go. We got it. So it was really easy. Let me summarize the steps once again to show you what mechanism was used. Step 1 was to get a key and set it as the environment variable. You'd have to do that regardless of how you did this. Step 2 was to take the inputs and outputs on our methods and convert them to Java records. And you could use an AI tool to get assistance with that process. A little involved this time because of all the nesting they provided, but still not too bad. Step 3 was to use Spring's HTTP exchange interfaces to set up the bean that Spring will use to do the networking on our behalf. Also, Spring includes the JSON starter, which includes the Jackson JSON parser. So all we have to do is use Jackson annotations if we want to customize the serialization and deserialization process. Once we did all that, it was simply a question of taking that interface, auto-wiring it into a service to give us an opportunity to simplify the API, make it easier for people to use, and then connect everything and run the tests, and it all works just fine. Now, I should point out there is an actual Java API for Gemini, but it's only available if you're willing to use Google's Vertex cloud service. So they have a Vertex AI cloud provider if you're interested, but then you need to sign up for the cloud service and give them a credit card and all that stuff. And if you're interested, be my guest. But I didn't want to go that far. I put all this stuff together in a couple hours, and hopefully now with this amount of guidance, you'll be able to as well. Let me point out that this approach, building the records, using the interfaces, setting up the pre and post processing, can be applied anywhere you have a RESTful web service. There are other videos in this playlist on the Tales from the Jar Side YouTube channel that show how to do this with Claude. In fact, the GitHub repository that contains the code I just showed you also contains a demonstration of doing a similar task with the Claude AI service. I have other videos in the same series that do something similar with the OpenAI tools, including DALL-E image generation and the Whisper audio-to-speech generation tool. So please feel free to subscribe so that you won't miss any further additions to this series and working with other tools and frameworks like LangChain or even Spring AI. Thank you very much for being here, and have a good day. Tales from the Jar Side, let's begin. Java, Kotlin, and Spring, oh my. Groovy, Gradle, don't be shy. Tales from the Jar Side, oh yeah. Crack open the code, let's take a ride. From design patterns to the latest trends, your weekly tech dose that